Thin white bands keep flashing beside Jupiter, like cracks inside the image feed. Not curved, not chaotic, straight. The detector tries correcting them out almost immediately. Infrared noise spikes across the frame. Pixels burn white for less than a second, then vanish again behind static. Another stripe appears somewhere else beside the planet. Closer this time. Jupiter fills half the view now, but the radiation damage starts before the probes even reach the atmosphere. It spreads far beyond the clouds into darkness that looks completely empty. NASA probes entering the magnetosphere started taking radiation damage long before reaching the planet itself. The instruments start failing while the planet still looks far away. The danger has no surface. Radiation cuts through the shielding faster than the systems can finish calibrating. Navigation lines flicker sideways across the display. One sensor freezes. Another restarts mid-scan. The bands remain visible anyway. The interference stops behaving randomly. In radiation this violent, the pattern should not stay stable. Instead, the same hard edges keep returning beside Jupiter, like the interference is following a shape. A pale stripe cuts straight through the infrared field and stays there long enough to watch it burn. The pale stripe is still visible when Jupiter turns beneath it. Cloud bands roll across the planet, while the red atmosphere turns slowly into darkness. But the white band does not rotate with any of it. It stays fixed above the shadowed side, while Jupiter turns beneath it. This is not moving with the planet anymore. Navigation overlays begin collapsing one by one. Safe orbital paths narrow across the display, while the probe keeps recalculating radiation exposure in real time. One route disappears entirely after the detector spikes again. Another path lasts 12 seconds before the radiation count jumps beyond shield tolerance. Jupiter's magnetosphere already forces NASA missions to treat the region like a survival hazard long before arrival. But radiation alone should not stay aligned through orbital movement. The bands remain aligned across orbital movement itself. That is where orientation starts breaking apart. A sealed craft still takes ionizing damage passing near the lanes. Sensor ghosts flicker across the interior displays. Static crawls through star trackers. Every escape route keeps drifting toward another wall of radiation farther ahead. Jupiter keeps turning quietly below the fixed white bars. Tiny points of light begin curving through the darkness beside Jupiter. At first, the movement almost feels reassuring. Charged particles caught inside a magnetic field do not travel randomly. They bend through space along invisible paths. NASA has tracked those particle flows for years around Jupiter's magnetosphere, where radiation stays trapped far beyond the visible planet. Jupiter is pulling the radiation into lanes. The white bars start looking intentional once the motion becomes visible. Streams of particles arc inward before collapsing into brighter belts wrapped around the planet. Some regions flare violently. Others stay strangely clean, almost organized. For a moment, the crossing finally seems survivable. If the lanes remain stable, routes can be predicted. Timing can be calculated. A craft could cross between the strongest regions before the radiation load overwhelms the shielding. No pilot could react fast enough to survive mistakes here anyway. Survival depends entirely on following the pattern correctly the first time. Then another belt brightens where no lane was expected. Navigation systems pause while new exposure maps redraw themselves across the display. One glowing rail bends farther outward than the previous pass predicted, stretching across orbital space several times wider than Earth. Jupiter keeps pulling particles into visible structure, while the safe paths quietly stop agreeing with each other. A black corridor opens between the radiation belts. For 11 seconds, the radiation drops low enough to cross. Navigation markers stabilize. The route cuts cleanly through the glowing lanes around Jupiter's night side. Then the safe gap lights up. White interference floods the corridor before the system finishes updating the warning overlay. A straight band cuts across the opening, bright enough to wash static through the external cameras. Instrument panels flicker inside the craft. One guidance display jumps several degrees off alignment and stays there. The route failed before the crossing even started. NASA spacecraft near Jupiter have already taken enough radiation damage to disrupt onboard electronics during mapped passes. But the new band moves across the mapped lanes instead of following them. The new stripe does not follow the magnetic arcs from earlier scans. It crosses them. That is where the models stop making sense. The organized belts are still there around the planet, glowing exactly where the models expected. But now another pattern keeps appearing through the safe corridors themselves, stretching thousands of miles across orbital space, like the exposure is ignoring its own boundaries. Shielding no longer guarantees anything after that. Every second inside the corridor becomes a countdown measured against systems failing faster than the route can redraw. Jupiter turns below in darkness, while crossing radiation bands continue drifting over regions that were supposed to stay empty. The crossing bands keep expanding, until Jupiter itself starts looking small beneath them. Thin white lanes spread outward through black space in every direction, wrapping around Jupiter like part of a structure too large to fully see at once. One strip brightens above the northern storms, another cuts silently across the dark side. Farther out, weaker bands drift beyond the visible edge of the magnetosphere and keep going. Jupiter controls the space around it. Jupiter's magnetosphere is the largest planetary magnetic structure in the solar system. It stretches so far that if human eyes could see it from Earth, the shape would appear larger than the moon in the night sky. But the scale changes once the radiation becomes visible. A tiny spacecraft moves between the glowing rails for less than a minute before the transmission begins collapsing. Static floods the transmission first. Then, orientation data fragments into partial coordinates that no longer agree with each other. The craft never comes close to touching the planet. It does not need to. The radiation reaches far beyond Jupiter itself. Body, suit, electronics, shielding, navigation, they fail out here first, inside darkness that still looks almost empty. The radiation grid remains suspended around the planet after the signals disappear, still shifting slowly across orbital space.